For the second half of this unit, we are transitioning from exponential functions to logarithmic functions. And you've probably heard the term logarithmic, but I don't know if you know what it means. So a logarithmic function is where if you have that positive base b, where b does not equal 1, in the exponential function y equals b to the x, then log base b of y equals x, where y is the log equal to the log and x is the exponent. And so what we need to do is know how these work. So basically, if we look here, we have that for a log base 3 is equal of 81 is equal to something. And so one of the things you want to make sure you know is ask yourself, what power must I raise b to in order to get y? So in other words, this would be saying 3 to what power gives me 81. Now, here's where most of these you should start becoming familiar with, but if you're not sure, you can do guess and check in this manner. In this case, I know that 3 to the 4th equals 81, so therefore this is equal to 4. The second piece you need to be able to do is take an exponential function and write it in logarithmic form. So remember, it's log base b of y is equal to x, where this is coming from b to the x equals y, just like we had the last few days. So that means that we're going to have log, my base is 3, so we write a little 3. 2 is that x, so that's going to be out here. And then 9 is my y, so it's log base 3 of 9 equals 2. What I want you to do now is give C a shot, enter your answer in the Edpuzzle, and then you can go ahead and check your work. For 2 to the 5th equals 32, we know that 2 is our base, so this is going to be log base 2. And remember, basically from exponential form to logarithmic form, the 5 and the 32 switch places. So 32 is before the equal sign, and 5 comes after. So it should be log base 2 of 32 equal to 5. The second part that you need to be able to do is go backwards from logarithmic form to exponential form. So just remember that it's log base b of y is equal to x, and we want to get it into b to the x power equals y. So once again, remember that these two are going to flip-flop each other. So it's log base 3 to, we know that 3 to the 4th power equals 81. So what I want you to do now is try E, enter your answer into Edpuzzle, and then go ahead and check your work. All right, let's go ahead and check this. We see that it's a base 5, so we know that 5 is my base. And then we talked a little while ago about how 3 and 125 flip-flop. We know that 5 to the 3rd equals 125. So 5 to the 3rd equals 125 would be my solution. The next piece to this lesson is going to get using the calculator. I want to start here and enter your answers in Edpuzzle. You should know how to enter these problems into a calculator by now. You don't need a graphing calculator, but you can use one. And then once you're done entering them, then go ahead and check your work. All right, let's try a couple of these. First one we have is 4 to the 3rd, so we're at 4. And we want to make sure that we use this little caret key right here. That means exponent, and that work is universal on all the calculators. Some of the calculators that I have that don't do order of operations, you have a y to the x button, so that would be your power button. But over here we have 4 to the 3rd. 4 to the 3rd gives me 64. Then we have negative 2 to the 6th. We need to make sure that we're using the parentheses because, oops, without the parentheses, that is telling us we're going to take the negative last, which would make a difference. So negative 2 to the 6th power is also 64 again. 10 to the third, this one should be one you can do in your head. The power tells you how many zeros you need to have. So this would be 1,000. Feel free to check that. 7 to the negative 2. I'm going to do this one in my head because this one should be pretty easy to do. Remember, we flip-flop it. So we get 1 over 7 to the second, which is 1/49. And then 1/4 to the negative third. We want to distribute that negative 3 in. So on the calculator, we'll check this one. We have 1 4th, parenthesis it off, to the power of negative 3, and you get an answer of 64 again. And the reason why this is 64 is because we would distribute that negative 3 and get 1 to the negative 3 over 4 to the negative 3, which flip-flops those to be 4 to the third over 1 to the third. 1 to the third is 1, 4 to the third is 64. The next piece is going to be to use the calculator to evaluate logarithmic functions and then write the function in exponential form as well. So one of the things I want you to make sure you're aware of is your calculator can only do a log in base 10. So if you have a log in any other base, it's not going to be possible on a calculator. So log to base 10 of 10,000 is basically saying 10 to the x power is equal to 1,000. And we just talked about that's 10 to the third. And so what I'm going to do is I'm going to use my log button on the calculator. So log, and you don't need to put the base 10 in there because your calculator assumes it's base 10, of 1,000, and we get 3. So then we can try log base 10 of 8. Well, 10 to the first is 10. So we know that our number is going to be less than 1. And so we go in here and we say this is going to be 10 to the x power is equal to 8. And so log of 8 is going to give you a big number of as far as decimal places. So we're going to round to 4 decimal places. So we have 9031. Now we can go ahead and just look at the calculator. We're not going to write the exponential form for this one. We have log of 1,026, and you get 3.011. Now in this fourth one, as you can see, we have a 5 there. It's a base 5. It's not that we cannot do this. This is saying that 5 to some power of x is going to be equal to 3. It's not that it's impossible, but for the purposes of a calculator and the fact that we haven't learned the rules yet for this, we're going to say here that this is not possible on a calculator. We'll learn later how to do that, but that's for another lesson.